name's Tim Mason. I'm Professor of Chemistry here, and I run the Centre for Sonochemistry. My main roles are research these days. I used to teach full-time, but now I run the centre and we attract quite nice contracts on a range of issues. The whole area of sonochemistry started many years ago here. The interest for me was that in metallurgy they used sorts of techniques that I wasn't used to in chemistry, and one of these was to use ultrasound for cleaning. And they had lots of cleaning baths, ultrasonic cleaning baths around. And these things would whir away and they'd put in a sample, and as they put the sample in it would clean, they took it out, and the sample was ready for their test or whatever. And it struck me, this energy that is being used to clean samples surely is the sort of energy that might be used for promoting chemical reactions, because my background was always in physical organic chemistry. That is to say, finding ways in which you can speed up a reaction, or at least to study the ways a reaction goes. Most people are familiar with using ultrasound to look at the fetus in the womb, so-called diagnostic ultrasound. Well, that's not us. We don't do that. We use ultrasound to cause changes in a body. So what we do is to use ultrasound focused inside the body to create enough energy to kill cells. And of course, if you target that at a cancer, you can start killing the cancer without chemicals, without even an operation. You can focus the ultrasound within the body and kill a cancer. The environmental aspect of our work is the use of ultrasound to prevent pollution or to correct pollution. For example, we can remove chemical pollution or we can remove biological pollution. Biological pollution might be, for example, algae growth, algal blooms. The type of ultrasound we use is power ultrasound, and that creates in water cavitation, acoustic cavitation. And you will have seen a number of experiments which demonstrate the effects of acoustic cavitation. The point about acoustic cavitation is that the collapse of these bubbles produce great energy, and the energy they produce can be harnessed to oxidize pollutants, chemical pollutants, or indeed to make algae very unhappy in water and cause them to fade and die. An area that we work in medical ultrasound is also the production of biocidal bandages. These are very important because, as you probably know, in hospitals these days there is quite a lot of something called nosocomial infections or hospital-acquired infections. One example of this is MRSA. So what we're doing is using a little bit of chemistry to produce nanoparticles, biocidal nanoparticles, nanoparticles that will kill bugs. And using the ultrasound, having produced the nanoparticles, to force these into fabrics. So the process, which is one that's funded by the EU on an FP7 project, is one incorporating about 7 different partners. We get a bandage, a fabric, we put it into a liquid, apply ultrasound, a bit of chemistry magic happens, we produce nanoparticles, and the nanoparticles are injected into the fabric by the ultrasound itself, a sort of synchronous process. These bandages are effective against most of the hospital-acquired infections that we've tried. They can be used as bandages themselves, or, also important, as fabrics for the making of nurses' uniforms, aprons, curtains, anything which might come into contact with superbugs and would then kill them. So, what are we going to be doing in the future with this subject? Certainly continuing with the medical ultrasound. That's a fantastically important area. Environmental protection, of course. There is always a need to look at ways in which you can protect the environment, avoiding treatments with chemicals. The wonderful thing about ultrasound is you don't know quite where it's going to lead you. We get down so many sidetracks at times that we don't know where we're going. But some of these oddball things really get into quite big areas. So we'll pursue as much as we can in as many areas as we can, and from this we will find some really exciting new science.